The absolute value of x minus 1 less than 6. Anytime you have something that comes out of an absolute value, it becomes positive, no matter what the solution is. So we can solve this inequality by breaking this original inequality into two pieces. One is going to be as it appears, like this. And then the other is going to be x minus 1 greater than a negative 6. Whatever it appears to be at first, and then you're going to change the sign of the number on the right and flip the inequality sign. So now, on the left-hand side, solve this and come up with x less than 6 plus 1, x less than 7. And then, for the right side, x greater than negative 6 plus 1, x greater than negative 5. Go to a number line and plot what we have. We need a positive 7 and a negative 5. So we'll put a 0 here and go 1, 2, 3, 4, 5, 6, 7. And then go back 1, 2, 3, 4, 5. It's greater than and less than, so we have to have open dots and then follow the pattern. X is less than 7, so we will go in there. And then x is greater than negative 5, so we have to go back this way. So they meet up. We're going to have this area under here shaded in. Test how this works out. Choose a number that's inside of the red area. We'll just pick 0. If I put a 0 in here, 0 minus 1 is negative 1. Absolute value of negative 1 is 1. Is 1 less than 6? Yes, so it works out and it's in the area. We will pick a number out here outside of the solution area. We'll pick 8. 8 minus 1 is 7. The absolute value of 7 is 7. Is 7 less than 6? No, it does not work out. That's why it's outside the area. And if you pick a number outside of here, you'll find that it doesn't work either. This problem is the absolute value of 3x minus 6. That should be a straight up and down line. And then greater than 18. So we have to break this up into two parts. 3x minus 6 greater than 18. 3x minus 6 less than a negative 18. On the left-hand side, we will have 3x greater than 18 plus 6, which is going to give us a 24. So x would be greater than 8. And on the right side, 3x less than negative 18 plus 6. 3x less than negative 12. You're going to have to divide by 3 to get x less than a negative 4. So let's go to a number line and see how this works out. We need negative 4 and 8. So here's 0, 1, 2, 3, 4, 5, 6, 7, 8. And then go back 1, 2, 3, 4 for negative 4. Open dot, open dot. According to this, it says x greater than 8. So we will go this way. And then x less than negative 4. So let's test this area. Let's choose 0. If I choose a 0 in the middle of this area, 3 times 0 is 0, minus 6 is negative 6. The absolute value of negative 6 is 6. Is 6 greater than 18? No. Choose 9 from out here. 3 times 9 is 27, minus 6 is 21. Absolute value is 21. Is 21 greater than 18? Yes. So this one works out. And then back here, let's choose negative 5. 3 times negative 5 is negative 15, minus minus 6 is negative 21. The absolute value of negative 21 is positive 21, and is that greater than 18? 21 is greater than 18, so yes, there are your solution areas. Our first move is to bring down x plus 3, and then we're going to write greater than 12. After this, we're going to write x plus 3 less than negative 12. We're going to have x greater than 12 minus 3, which turns out to be x greater than 9. We will move the 3 to the right side here and change the sign. X less than negative 15. Alright, so we'll make a number line, and we need 9 and negative 15. So we're going to go over this way a little bit with 0 and go 1, 2, 3, 4, 5, 6, 7, 8, 9. And then go back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 for negative 15. We need open dots. And now x greater than 9 is going to be over this way, and then x less than negative 15 is going to be over this way. So we picked a number here, negative 16, and put it in, and it came out to be a true statement. And over here we picked out 10, put it in, and it was a true statement. So the shaded areas represent the solution to this absolute value inequality. The first move on this is to write 2x plus 6 greater than 12, and then 2x plus 6 less than negative 12. The left-hand side here will have 2x greater than 12 minus 6. That will give me a 6 on the right, and divide by 2 to get a 3. On the right side we have 2x less than negative 12 minus 6, and that'll be a negative 18 on the right. We will divide by 2 to get a negative 9. Now we must graph this. Here's the number line. We need a negative 9 and a 3, so we're going to go here with the 0 and go 1, 2, 3. And then on the left we will have 1, 2, 3, 4, 5, 6, 7, 8, negative 9. Those are going to be open dots. X greater than 3, x less than negative 9. Your solution areas should be in here. We can test it out real quick. Put in 0. If I put a 0 in here, I get 6. Absolute value is 6, and it is not greater than 12. We can even put in an 8 and see what we come up with. If we put in an 8, which is out here on this side, that would be 16 plus 6 is 22. That is greater than 12. Try a negative 7. If I put a negative 7 in here, that's negative 14 plus 6 is negative 8. And absolute value is 8. That's not greater than 12. So this still remains a no solution area. And if you put a negative 10 in, it will turn out to be a true statement. Our first move here is to write negative 3x minus 6 less than 12, and then do negative 3x minus 6 greater than negative 12. Alright, so we're going to have on the left-hand side negative 3x less than 12 plus 6, which is going to give us an 18. And then divide by a negative 3 and flip the inequality sign to get x greater than negative 6. On the right side we will have negative 3x greater than negative 12 plus 6, negative 3x greater than negative 6. Divide by negative 3 and flip the inequality sign to get x less than 2. So now we go to the number line here, and we have to have a negative 6 and a positive 2. So there's 1, 2, and 1, 2, 3, 4, 5, 6, negative 6. Open dot, open dot. X is less than 2, and x is greater than negative 6. If we pick out 0 from in here, put a 0 there and come back with an absolute value of negative 6, which is 6, and that is less than 12. If you choose a value out here or here, it'll come out to be a false statement. Here's a special case, and this one is the absolute value of x plus 4 greater than negative 3. Think about this. whatever number I put in here and then add 4 to it, and whatever solution I get for that, I find the absolute value and it comes out to be positive. Can you give me any positive number that is going to be greater than negative 3? 4. Anything else? 2. So how does it work out? Look at this. We will work it out the way we did the other ones. X plus 4 greater than negative 3 and x plus 4 less than 3. So, on the left-hand side, we're going to have x greater than negative 3 minus 4, x greater than negative 7. And on the right, x less than 3 minus 4, x less than a negative 1. Let's see what happens when we graph this. We need a negative 7 and a negative 1. Alright, so we'll go back here, we'll make this 0 and go 1 for negative 1, 2, 3, 4, 5, 6, 7, negative 7, open dot, and then we'll go open dot here. X greater than negative 7, and then x less than negative 1. Okay, from the way it's drawn, it looks like that the solution would be in here. So let's pick a number. We'll make this negative 5. If I put negative 5 in here and add 4 to it, I get a negative 1. What's the absolute value of negative 1? Is 1 greater than negative 3? Yes. So we know that we're going to have this, but pick a number outside of this area. Come over here and choose a positive 1. If I put a 1 in here and add 4 to it, I get 5. The absolute value of 5 is 5. Is 5 greater than a negative 3? Yes, so we have this out here as well. Let's go over this way and do negative 10. If I put a negative 10 in here and add 4 to it, it's negative 6. Negative 6, the absolute value of negative 6 is going to be positive 6. Is that greater than negative 3? Yes. So the solution to this isn't just on the graph in this area. It also includes this and this. And when it has all three areas, the solution can be written as all real numbers. Here's another special case. The absolute value of negative x plus 6 less than negative 2. Think about this. Absolute value. What sign will the number have that comes out of this absolute value quantity? What sign will it always have? Positive. Can you give me any positive number that is less than negative 2? No. So we will check it out. Negative x plus 6 less than negative 2 and negative x plus 6 greater than 2. So we'll have negative x less than negative 2 minus 6. On the right, that's a negative 8. Divide by a negative 1 and flip the inequality sign to get x greater than 8. On the right, negative x greater than 2 minus 6. Negative x greater than negative 4. And x, when you divide by the negative 1, x less than positive 4. So on the number line, draw this out. We need a 4 and an 8. So here is 0, 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to go open dot, x greater than 8, x less than 4. Pick a number in here. 5. Negative 5 plus 6 is 1. Absolute value of 1 is 1. Is 1 less than negative 2? No. Over here, in this area, pick a 10. Negative 10 plus 6, negative 4, absolute value is 4. Is 4 less than negative 2? No. And over here, 0. If I put a 0 in here, I'm just left with a 6. Absolute value is 6. Is 6 less than negative 2? This one has no solution.